In the earlier classes, we are explaining about all the scheduling algorithms. Now, all the scheduling algorithms with respect to some situation, we have to use that in the previous task. Now our task is we have to maintain the one process queue with a different algorithm. We have to follow at a time what happens to the CPU. That is the concept of multi-level scheduling algorithms. The same way in the previous algorithms like FCFS and priority and SJF and round robin, what happened was we have to follow only one method. We have to follow one method. Depending upon that, your task will be completed. We have to calculate the waiting time. Now, here no waiting time calculation. Our task is completed or not, we have to find out that. That's all. Now, what happened was in the multi-level scheduling algorithms, is a naming itself multi-level. Multi means more than one. More than one. Everyone knows that. Whenever you following the queue, depending upon the task, you have to managing with one algorithm, you have to task will be completed. Then particular that task will be useful for only particular process, not all the process. One process will be used the FCFS, another process used for priority, another process shortest job first, another process we have to use the round robin. We have to, that is called the multi-level scheduling algorithms. Now, whenever you come to the multi-level scheduling algorithm, there is two types of process you have to work out. First one is a foreground, next one is a background. What is meant by foreground, what is meant by background? Whenever, for example, you are executing, first you have to execute one process, that is a high priority. You have to following the scheduling task, priority algorithm, you have to execute. That is the work will be done in the background. That will be take 5 seconds. In the foreground, what happened? Don't wait. Foreground, you have to use the another process, try to execute. On that time, what happened was, the CPU burden is more. This concept is derived from the Unix platform. This is a very, very old concept, 1950s or 1940s concept will be there. On that time, what happened was, foreground process. Foreground process means you have to see with your eyes. Background process you are unable to see with your eyes. After completing the task, what is the problem you are facing? Then you have to identify. Foreground process means depending upon the priority task, it will be executed. Background process, you are given the most of the time, you have to give the priority to the foreground, not background process. Not background process. Because background process will be executed, long time process you have executed in the background. Where less time is there, automatically that will be executed in the foreground. Useful for understanding. That is the concept of multi-level scheduling algorithm. And the next point is the multi-level scheduling key. There is a partition of separate queues in the batch processing wise. For example, in the queue, if we maintain in the queue for a CPU, totally 10 process will be there. 2 process will be maintained the priority algorithm. 2 process will be following the round robin algorithm. You have to form a different groups, different batch files you have to execute. That's why you have to form a different groups. Depending upon the groups, we have to see that we have to execute in a properly whenever CPU is not overheaded. That is a major task. If the all at a time 4 processes at a time you have to execute, automatically CPU is overheaded. Automatically you are facing the lot of problems. Because of that one, you are not maintained the proper way in the foreground and background process. Automatically you are failing process in the multi-level scheduling algorithm. If you maintain the proper way, automatically you have to follow up the things in a proper way. You have to see the most of the priority given to the foreground process, not a background. That is a major task. And next one is, in that this is the multi-level scheduling is the preemptive scheduling only. Example, preemptive scheduling only. In that, foreground process will be having the more priority when compared to the background process. Why you have to given the priority for a foreground process means, if the multi-level scheduling the different task will be there, if any problem background process, after completing the task you find out the error. In the foreground process you identify the errors. If you face the problem, you identifying the error, then you have to stop the query and again you have to execute later. But background is not, once you have to completing the task, then only you have to find out the error. That is a major default problem about the background queue. And the next one is, let us consider the one example for that 5 queues are there. There is a 5 different level queues are there. One is a system process, next one is the interactive process, interactive editing process, batch process and student process. Now what is meant by system process? System process inbuilt files you have to execute. That is the most priority task. Inbuilt system process, already inbuilt files you have to execute. For example, if you are executing the C program, first you have to execute include stdio.h file. That is the most priority. That given the most priority. In the execution part, that is a system process. Interactive process means whenever that process will be combined with the number of system user defined functions, that is called as the interactive process. That include stdio.h linked with the system defined files. That will be the interactive process. If any changes will occur those files, we have to change will occur, again we have to form a queue. That is called interactive editing processing. Next, batch processing. If the same type of processing will be keep it on one file, at a time you have to execute, at a time you have to sending in the queue, that will be executed. Student process means low weight process. Low weight process. It means, what is the meaning for low weight process is, what is the meaning for low weight process? In the student process, the student process individual process are the processing time is very less. Those are all called as a student process. Processing time is very less. Time quantum of the student processing is very less. Those are all called as a student processing threads. That is a low priority. When the time execution time is a low, automatically the low priority process will be there. The 5 process will be there. One is the system process, next one is the interactive process, next one is interactive editing processing, next one is the batch processing, next one is the student. Which one out of 5, which one is the overhead? Batch processing is the overhead for the CPU. All at a time you have to execute. For example, 100 systems or 100 programs or the same method will be executing. All at a time you have to sending to the queue. Automatically CPU overhead is coming. Due to that, sometimes CPU will stop. CPU has some problem. That is a major overhead of the multi-level scheduling algorithm. And this is the diagram for that. Highest priority is the system process. Next one is the interactive interactive editing, batch processing, student processing has a low priority. Why you have to change the color of batch processing? For understanding purpose, you have to change the color. That is, the batch processing is the most overhead process in the multi-level scheduling algorithms. And next one is, whatever the parameters you have to follow, what are the parameters, what are the difficulties you are facing in the multi-level key scheduling. Number of queues in the system. Whenever in the number of queues, queue not will maintain the single. You have to, depending upon the task, you have to maintain the number of queues, and the number of scheduling algorithms you have to follow in the different queues. And same queue we have to follow the different methods. We have different scheduling algorithms you have to follow, and this method determines the process upgrading for the higher priority queues. Whenever one process will be not executed in that other, why it will not executed? That will be the major step for feature enhancement of that particular process. Means, for example, in the life cycle, what happened was, why somebody suggests one route, you have to go there, you have to reach it to the very quickly, but you are following the another route. You are following the another route, but these people, why following this route? Why I am following another route? You have to think about that. In that way, if you think, automatically that is a step for minimum step for feature enhancement. In this route, what happened was, no traffic, and you have to reach it very safely. In this route, traffic is there, and is the biggest problem. Every time you have to, clutch will be used, you have raising under the other time you are lose your petrol. That is a major disadvantage. But it is the shortest path, but not comfortable. This is when compared to this one, this is the longest path, but it is a suggested one. It is comfortable for journey. In that way, whenever one method is chosen to determine the one queue, that method is not applicable to that particular program. We have to choose the another way. We have to choose the another queue. That's not a problem. But why you is not comfortable? That program is not comfortable for that queue. That is the major task. If you understand that problem, that is a that is a step for feature enhancement. That is a very, 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 very critical path in the multi-level scheduling algorithm. And the next one is, in that what happened was, determining the lower priority queue. How to determine the lower priority queue? Here, whenever processing time is very low, or bursting time or processing time is very low, and that time they given the less priority. That is a major task. And whenever determining, when you entering into the queue, what type of process you have to need for the services, what type of process queue you have to follow, that is a major, that will be checked in the multi-level scheduling algorithm. That is the end of the today's session. This is a very simple concept. That is the end of the today's session.